Take a look at these rocks. Their surfaces are covered with dark spots and patterns that we often associate with living organisms such as microbes or bacteria on Earth. However, these rocks do not come from Earth. They come from Mars. They were found by NASA's Perseverance rover, and scientists say they have been searching for exactly these kinds of traces for years. In fact, the research team is even talking about a potential biosignature. But what does that mean? Have we finally found proof that the red planet once harbored life? Well, that's exactly the question. To be certain, the samples must be brought back to Earth and analyzed. Only here can all the tests be carried out that can provide definitive answers. However, if it's confirmed that we have proven the existence of life on Mars, it would be an absolute turning point for humanity, and we would no longer have to wonder whether we are truly alone in the universe. So, be sure to stay tuned until the end to find out exactly what Perseverance has found on our neighboring planet. Today, Mars is considered the prime example of a supposedly dust-dry, hostile world. But that wasn't always the case. It's now clear that until around 3.5 billion years ago, the red planet was hospitable to life and adorned with lakes, rivers, and even a full-fledged ocean. And Jezero crater, which has been explored by NASA's Perseverance rover since 2021, was also once located in a much wetter environment. In detail, the crater may have once been home to a large lake and offered a welcome home to any Martians. At that time, several rivers flowed into the impact basin, which also contained some important chemical building blocks of life. Against this backdrop, it's not really surprising that NASA is searching for potential signs of life here of all places. Last summer, Perseverance finally reached a bright rock formation consisting of fine-grained clay minerals in the former Neretva Valley's River Valley, revealing something that immediately caused great excitement among experts. Since the rock was covered with tiny dark spots and larger circular structures, the researchers immediately nicknamed the patterns leopard spots and poppy seeds. But what is the significance of this? Well, quite a lot. To our untrained eyes, such spots may not look particularly spectacular, but that changes abruptly when we realize how they came about in the first place. On Earth, such patterns are often associated with microbes, and we can think of them as a kind of fossil diary that shows that the sediment layers were once teeming with life. The assumption that we are dealing with the result of biological processes here would therefore not be far-fetched. But what about Mars? Well, to clarify this, Perseverance pulled out its entire arsenal of analysis tools and took a close look at the striking rock. Given the potential significance of the discovery, NASA experts decided to drill into the rock formation and secure a sample for further investigation. In fact, one of the rover's central tasks is to collect such samples so that they can one day be brought back to Earth. Perseverance set to work and sealed the sample, nicknamed Sapphire Canyon, in a metal tube. After drilling, Percy even took a selfie showing the freshly drilled site. But at the time, no one suspected that analysis of the sample could change the history of space exploration forever. The search for life on Mars has been going on for decades. In 1976, Viking 1 and 2 were the first space probes to successfully land on the red planet and conduct experiments specifically designed to detect life on Mars. Essentially, nutrients were added to the soil to see if any organisms would feed on them, and the reaction was astonishing. The soil suddenly began to release gas as if microbes or bacteria were digesting the nutrients. However, the initial excitement was followed by great disillusionment because it was later realized that the results could also be easily explained by reactive chemicals in the soil. The involvement of living organisms was simply not necessary. But in the 2000s, the big bombshell finally dropped. Rovers such as Spirit and Opportunity collected data suggesting that Mars was once very similar to Earth and billions of years ago had numerous rivers, lakes, and even a huge ocean. More specifically, Mars' wet phase coincided with the period when life was gradually blossoming on Earth. And we know that conditions on the red planet at that time would also have been potentially hospitable to life. Of course, this discovery opened up a whole new perspective for experts, and this is where Perseverance comes in. The rover is equipped with several instruments that can be used to examine samples for potential signs of life. First, there is PIXL, an X-ray fluorescence spectrometer that can determine the elemental composition of the Martian surface. Then there is the Sherlock spectrometer, which uses ultraviolet lasers to reveal the exact mineralogy and organic compounds. And when Perseverance pointed these instruments at the aforementioned sample, it revealed exactly what the scientists had hoped for. The dozens of leopard spots, each about a millimeter in size, contain a mixture of mineral iron phosphate in the form of vivianite and the iron sulfide graphite. Typically, these two minerals occur on Earth in water-rich environments. But the edges of the spots and grains prove to be particularly exciting. This is because they contain chemical reaction fronts that indicate reactions between the minerals and organic carbon compounds. And here's the thing, on our blue home planet, microbes are usually involved in this type of mineral formation. However, rock analysis on Earth is somewhat less complicated than on an alien planet. And so it came to pass that last year, scientists meticulously evaluated the data, examined the composition of the sample, and developed hypotheses about how these unusual spots on Mars might have formed. To this end, the experts examined all known non-biological explanations, from chemical reactions to mineral formation to sedimentary processes, but they could not find any that explained the patterns as well as the hypothesis of a biological origin. This means that the mysterious spots could indeed be traces of ancient Martian life, even if definitive proof is still pending. In principle, the researchers explain that such iron-containing sulfides and phosphates can also form purely geochemically. However, and this is the crucial point, this requires either heat or the presence of an acid. Co-author Michael Tice of Texas A&M University says, however, the investigations possible so far indicate that these rocks were never heated sufficiently to produce the leopard spots and poppy seeds. No clear evidence of an acidic environment has been found to date either. In view of this, Tice comes to the following conclusion: if this is confirmed, we must seriously consider that these formations were produced by bacteria-like organisms that lived in the mud of a Martian lake more than 3 billion years ago. The bottom line is that this classification fits perfectly with what scientists have long suspected about Mars. If microbes had lived in the mud of Jezero Lake and used sulfur and iron as energy sources, they would have left behind leopard spots and poppy seed patterns as waste products. So, it looks very much as if the mud was once teeming with microorganisms whose traces were preserved when the rock hardened. But why don't the experts call a spade and say that they have found extraterrestrial life? Well, quite simply, because extraordinary claims always require extraordinary evidence, and to provide this, the sample must be brought back to Earth. For discoveries like these, NASA uses an internal evaluation system to assess the probability that a find represents a sign of life. In simple terms, we can think of this as a scale ranging from rather vague indications to multiple confirmed signs of life. And the results of the Perseverance sample fall roughly in the middle range. In other words, they are promising but not yet conclusively confirmed. And as I said, such confirmation is only possible on Earth. No matter how clever the rovers are, no machine on Mars can replace the variety of analyses available to us in Earth-based laboratories. However, it's in the nature of things that transporting the samples is extremely costly. Perseverance has already deposited several samples for later return to Earth. But then you also need a rocket that launches from the surface of Mars and takes the samples into orbit, and then another spacecraft that collects the samples there and flies them back to Earth. That may sound quite simple in theory, but in practice, this undertaking is so complex that NASA had difficulty implementing such a mission for years. If you like, this would be the most expensive delivery service in the world. But Mars sample return is now taking shape, and if all goes well, the Perseverance samples could arrive here in the 2030s. And let's imagine that the subsequent analysis really confirms what is currently suspected. What would that mean for us as humanity? Well, it would change our view of life itself, of our own existence and how unique we are in the universe. Perhaps it will ultimately even show that life can arise wherever conditions allow, and not only where a chain of improbable coincidences occurs. British science fiction author Arthur C. Clarke once said, "Either we are alone in the universe, or we are not." Both possibilities are equally terrifying. And perhaps we're already on the verge of finding out which of these terrifying possibilities is actually true. But the frightening possibility of missing another new video from us can quickly become a thing of the past. Simply click on the thumb icon and subscribe to stay up to date from now on. See you soon.